consider every option. You don't need to, but that's one way to do it. Which works now because how many possibilities are there here? Only 4, right? Because we have 2 people talking, so we can do that. If we had more people talking, then it would not be too good to do that. She's saying,
are you guys working together?
he is. Because we need 3 people. Okay, Jules, come. Okay, so, come. Yeah, we don't need the chair now. Come. No, you don't need the chair. Come, Jules. So Harper, who do you want to be? Do you want to? We have 3 roles. We have the person that comes in and talks to the. Okay, Harper is the lady that's going to come and talk to the. So you're who do you want to be? Ted or Zippy? Chill. It doesn't really matter. Zippy, you're Ted then. Okay, great. So you're Zippy. Oh, you don't have your lines. Here, you don't have your lines. No, Harper, you're just gonna help. They are talking to you, but now you have to figure out what they are. Go ahead.
Between Zippy and me, exactly 1 is a night. That is a day.
Let's do it again.
Between Zippy and me, exactly 1 is a night. That is a day.
So now, let's see.
He's telling the truth because he's saying that one of us has to be one and
You're saying that Ted is telling the truth, okay? And that he is lying. And why is that? Because he went up, he has different options? What do you mean he has different options? Because he went up, he has different options? What do you mean he has different options?
One of us has
Okay, but remember, can anybody on this island say I am a knave? No, right? That's one statement that nobody on this island can make. I am a knave, right? Because a knave. Well, let's go back to that. Why can't a knight say I am a knave? A knave, yeah, exactly, a knave, yeah. A knave cannot say that because he would be telling the truth. And a knight cannot say because he would be lying. All right, so he's saying between Zippy and me, exactly 1 is a knight. Okay?
We have to figure out which one.
Well, if he's telling the truth, he might be lying. If he's lying, what would be true? Suppose he were lying. Then what would be true? He said. If he's saying only 1 is a knight, suppose that's a lie, what would be the case? That either both are telling the truth or both are lying. Okay? That's the negation of the statement. Okay? Now he's saying, now, I like the way you reason through this. Ted said, between Zippy and me, exactly 1 is a knight. And now, but he's saying Ted is a knave. So you're saying that he's telling the truth. Okay, so let's assume that he's telling the truth. If he's telling the truth, what does that make it, according to his statement? Why is it? A knave. So he would be lying. So the the truth of his statement would be, so this would be a lie, right? Teddy's a knight would be a lie. So the truth would be that Teddy's a knight. So, okay, let's go back. You're saying that he tells the truth. He's a knight, and he's a knight. And we're just checking whether that is consistent. Whether, if we see a contradiction, something weird come up, we say, oh, there's something wrong. But you're saying that he's a knight, and he's saying only one is a knight. Exactly one. So if he's a knight, that would make him a knave. And then he's saying Teddy's a knave, which would make him a liar. So it's okay. He's a knight and he's a knave. Very good. Now we have problem number 2, and for this you may need more paper, okay? You may need more paper, that's why I put scrap paper here. So you have a circle. That circle has 16 dots, okay? That circle has those 16 dots. And if you're going to play, you have to find someone to play with, okay? But listen to the rules. You have to listen to the rules before you play. So the circle has 16 dots, okay? And you're going to take turns, okay? One player starts, the other one, you take turns, the other one goes next, and so on. You alternate turns, and then you take turns, and then what? Yes, the segments cannot cross each other. So you have this, you have your circle with your 16 dots, and the first player will do this, and then the other player will try to connect 2 dots, but you cannot cross another line that the other player drew.
What are yours?
What?
What are yours?
What do you mean, what are yours?
What are your lines?
You are, so if you're playing with him, somebody has to start.
What about you have your own line?
No, you cannot cross your own lines. No, you cannot cross your own line. You cannot cross any lines. That's a good question. Thank you. You cannot cross any lines. Okay, you draw a line, and you let the second player draw a line, and you keep drawing lines. And then you have to see who wins. Okay? The player who draws the last segment wins. We're just going to try it out for a while. We're just going to try to see if we can find a pattern, if we can find a strategy. So,
We have to play.
better with a pencil. Better with a pencil. You can start. No. Two people have to play. Two people have to play. You gotta take turns. You can play with Geffen. You gotta take turns. You can play here and then there, and then that's why I put more paper there. I want you to play. Yes. Yes. Yeah, you gotta connect two, but you just cannot cross the line.
You just cannot use the same line.
Yeah.
You can't.
The only restriction is that you cannot cross.
Eventually, it becomes impossible.
Yeah, so the player who draws the last segment will win. So who wins according to you? The first player or the second player? You won? Were you second or second player? You have to keep track of who's the first player and who's the second player. You gotta keep track. Who started? Did you start? You were first player and you won. Okay? So let's see if we can see a pattern here. Well, you could. That's a segment. You're connected to. That's fine. Okay, a question that's coming up a lot. Been asked 3 times already. If you have a circle like this, and you have two dots here, can you draw a segment? Yes, of course.
You don't win.
Yeah, you can connect those dots, that's fine.
Done, done, done. Done, done. I gotta wait at our game is still going on.
Who won here? First or second? I just want you to keep track. Who wins? First or second player?
Yes.
Yes.
I was the first player. Oh, you just crossed the line. You just crossed the line.
Yeah, and they won't be crossing, yes. Yeah, exactly.
That's why I'll be. Alright, we can still play. Alright, so why did I erase it? Alright. Are we done now? So let's start again. Yeah, but why? I'll keep your eye
That's why I put scrap paper on the table so that you can use it. Now I'm going to give you a hint in a few minutes. Keep playing.
Doesn't it say that
And I might give you a hint very soon.
There is no more movement.
Now, do you think
Oh, they
that
cannot cross each
Do
other.
you think that 16?
Oh.
Do you
I
think
may
that
have read the
16
problem
points?
I went
That's
last.
This is the same line.
You crossed.
Two dots, the same line.
Oh, no, yeah, I did. So, can we drop this and that side really make that one?
You guys are entirely right. I cheated, I'm sorry. You can win that game. You can win that game. I told her the rules wrong. There you go.
Let's see. Now, I'm going to give you a hint. If you notice, you have like too many options right now. So one strategy when you're dealing with a math problem, sometimes the problem may look like you have too many options. The problem may look too complicated. So one thing you can do is this. Listen. One thing, instead of considering a circle with 16 dots, consider one with only 4 dots. It preserves the same structure of the original game and only plays 4 dots. And try to see if you can find a pattern. And then after you try 4, maybe try 6. Maybe try 8. Maybe try 2. That's a different game. But you're using an example that is simpler than the original that might shed some light on the problem at hand. 16 points is just too many. You start drawing second lines and it's too many. So now his strategy is, oh, well, that's 3. Try 4. Try 4 for now. Try 4. Let's see. Let's play with 4. Only 4. 16 is too many points for now. We will look at it later. We have 4 points. Try it. Play. Go. Oh, you want to play? Go ahead. He goes first. Now you go. Go. Good.
What if I play this?
Who won? Okay, now play. Now let him start. Let Felix start. You Felix, start. With four, yeah. Let's see if we can see a pattern here. Now you play. Go. Oh, who won now? Oh, so did he play first or did he play second? No, did he play first or did he play second? Did he start the game or did he start? And who won here? And who won here? Oh, so here, one player, who won? The first or the second player? First or second? Yeah, here, first or second? Exactly, right? So do we see something? Why? So now that's a conjecture. What's your name? Stella. Stella is saying that the first player wins. Now that is a conjecture. She thinks that's going to happen, so you make a conjecture. Oh, I think this is then. Now you have to try to find a justification for that. Is that the case? Is it true that the first player always wins? Let's see. That's a conjecture. You make a conjecture. I think this is what's happening. Okay.
What about even and odd?
Did you try 6? Let's play. Here you go. Yeah, go ahead. That's what we call getting your hands dirty. You know, when you do that, you have to get your hands dirty. It's not that the idea is just see the problem.
Let's test. How many do you expect we're going to get? How many lines do you expect?
I think you crossed yourself. They're not crossed yourself.
So you can't cross the line.
Now we have to that's the now you have to now think about it. Now suppose
Kind of scoot over and work with them, right?
Is that pattern there? Let's try it. It's interesting. Let's try with 7. You go first again. I'm just doing a simple stuff. I'm doing those. I like to see what happens. You start first, right? You started first.
there are 3 moves left.
I don't have anything, right?
3 moves left.
So you win again. How many counts? How many lines?
It's a scratch.
See that?
I'm cool. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, I think. 1, 2, 3, 4, 5, 6, 7, 8, 9, 11. It's a pattern, I think. It's always first one win. Is that right?
And it counts for 2. 5, 7, 8.
Connect those.
Try to 8. Sorry.
This one. Let's see, let's keep playing. What do we have here? Let's play with 4. With 4, who wins? Play, you. You go. It's easier if you hold the pencil. Whichever way you want, just touch it. Just connect 2 dots. Okay, so I'm gonna go here. You go. Okay, and I'm gonna go here. Now you go. Can I play? Can I play? Where? What can I do? Oh, that's okay. That's already taken. That's already taken. Can I play? Where? Okay. How? How? Let's go again. Let's go again. Let's go again. 4 dots. You play. Okay, you connected these two. Okay, so I connect these two. Go ahead. Okay, I'm gonna go here. And then you're gonna go. Oh, you cross the line. You cannot cross the line. That's one of the rules. You can't cross the line. It's there. And then who wins? And then you win. That's right. That's right. And then you win. Did you play first or second? Did you? Who started the game? You played first. So you played first and you won. So try with 4, try with 6. After you're convinced with 4, you may try 6 points.
That's all right. You go first.
But why does that matter?
So, let's keep track of who's doing tries. We're going to one try.
Wait, let me see. Wait, we're gonna.
Oh, you can track with dots, like lines.
Now you're trying to collect information. You play 4, you play with 6, you play with 8. And now you're trying to find a pattern.
Okay, so you took one try.
Let me think of which way to do it. Maybe I'll do it.
You know how you do it this way? Like when you just draw a line for every turn you take.
I don't want to do Kelly.
Okay, so why is that?
I could do process of life.
There's always one more. That's a great observation. And then why does that matter? So if there's one more on the number of dots,
I understand. Sort of.
why? How many dots do we have? Do we have an even or an odd number of dots?
Let's try some odd numbers.
When we were playing 6.
Let's try odd.
Yeah, we can use the same
Second was
argument.
odd.
I know, I picked you on
Now
purpose.
let's consider that when you have 6. Who wins? You say that how many segments can you make? Okay. Okay, so
3 plus 2.
notice that the same
line.
will ask you
We found the pattern. There's a 2-line difference.
11 plus 2 equals 13.
3, 5, 7, 9, 10, 11, 13. So 9 we can conjecture would be 15. So what's the relationship between 3, 1 more, 2 more? So there's a relationship between, here's a relationship here. Between these two numbers is 0. Between these two numbers is 1. Between these two numbers is 2. Between these two numbers is 3. Between those is 4, 5. So, how can we write this as an expression? So, ouch, Judy, that's my hand. That's my finger. So, what can we say about 15? Let's look at the table. What can we say about, how can we write this as an expression?
Look at me.
Now, I wanted you to see something. Please pay attention here. This problem, when you first see it, and you start playing, and you have 16 dots, is it easy to play?
Yes.
It is. At first, when you first have it, when you first saw it,
Yes.
it was.
I won. One for me.
Yeah, I mean the rules are simple. Yes, the rules are very simple, and that's good. The rules are simple. All you have to do, you connect to the second player, and then the second player, the third player, and so on. So the rules are simple and easy to follow. All you're doing is connecting dots. First player, second player, third player, first player goes again. Second player, first player wins. So the point is, when we consider 16, it was way too many dots. So one strategy we decided to use was, let's consider a smaller case, one with 4 dots, and then you play with that. Then you can try with, you may try 3 or 5 or 6, okay? Now, some of you were convinced that, or had the feeling. You had the feeling, you made the conjecture that the first player always wins. But why? So now we can be a little more methodical and try to organize the information that we're getting. So let's organize the information that we have. So I'm going to make a chart, and charts are usually nice. It's a good way to organize information that then we can see. So I'm going to choose the number of points and the number of segments. The lines that we draw, let's call them segments. Okay? So, let's see. Let's go slowly. So, if we have one circle with 2 dots, who wins? First player. Right? And how many segments do we have? We're going to write the winner here. The winner is the first player. Okay, and we have, say, 2 points, right? So, I'm going to make a big chart. What if we have 3 points? 1, 2, what if we have 3 points? First player goes. Second player goes. First player goes again. And who wins? First player wins. And how many segments do we have?
3.
So hold on a second. First of all, let's stop for a minute. These are 2 points. On the plane, what can you do? If you have 2 points, how many points do you need to draw a line? How many points? If you want to draw a line, how many points do you need? 2 is enough, right? I can have more, but if I have 2 points, it doesn't matter where they are. If I'm on the plane, if I have 2 points, I can always connect them, right? Okay? Now here I have 3 points, these 3 dots. And what shape do you see inside of that circle? Okay, so here we have a line, here we see a triangle. So these are different observations that we're making. So now, if we have 4 points on the circumference of that circle. If we have 4, how many, so let's see, first player goes? First, second, first. How many segments do we have? 5. And who wins? Who wants to do the next one with me? Who wants to play with me here? Want to come? So I'm going to do this one. 1, 2, 3, 4, 5. You go first. I'll let you go first. 1, 2. Did you go? 3, 4, 5, 6, 7. Is that it?
Yeah.
So 7 segments, and who wins? The first one wins again. Now, I'm going to do something else next to this. Here we see a line. Here, or a segment. Here we see a triangle. Here we see a quadrilateral. It's a polygon of 4 sides. We see it's a quadrilateral. It's a polygon that has 4 sides. And here we see a.
You forgot to put the middle.
Oh yeah, I will do it just now. But what do we see here? How many points do we have here? 4. Like the 4 corners of a quadrilateral. 3. Like the 3 corners of a triangle. What about here? How many? Yeah.
Hexagon.
We have 5 points. We have 5 points. So we see a. What is that called? A pentagon is a polygon with 5 sides. Right? We have a pentagon here. And then, so we have 5 sides, and then we have 2 more. Those are called the diagonals of those. We call them the diagonals of those polygons. But that's just an additional observation that we can make. But we're not done. Hold on. Let's keep going. Let's keep going with our chart because we wanted to, yes. Oh, please. You know what it is? It's down that way. To your right, I think after that red. Okay. So let's see. 6. Why do we have 6 points? Segments. Why do we have 6 points? Why do we have 6 points? 1, 2, 3, 4, 5, 6. Why do we have 6 points? Who's going to win? Look, we can connect all these and we have a, what do we have?
Hexagon.
A hexagon. And now, here, we have 3 of those diagonals. So we have 6 plus 3 is 9. So who wins? First wins again. So now, do we see a pattern?
Yeah.
So what do we expect when we have 7 points? Without even drawing it, what do we expect? 1, 3, 5, 7, 9. We expect 11. And we're going to check that. And then, what do we expect for 8? 13. What do we expect for 9? So let's go all the way down to 16. What do we expect for 10?
17.
And 12?
19.
13?
21.
Whoa, thank you. 21. 14. Well, I'm going to do 14. 14. The number of points and the number of segments. 14 we expect, we said 23, good. 15 we expect. 16. So now the question is, who wins that every time? Guessing. Why?
Well, I wanted to say something that
Go ahead.
wouldn't be correct because you skipped 11.
I skipped what?
11.
I skipped 11. I apologize. Oh my goodness. Oh my goodness. Thank you. 11 is 19. Thank you. That's a great observation. 12 is 21. Right? 13 would be 23. Thank you for that observation. This would be 25. This would be 27. And this would be 29. Thank you, Gavin. That was a great observation. So now, but who wins? Why does the first one always win? How many moves does this game have?
2.
What can you tell me about the number of moves? The number of moves is always odd. The number of moves is always odd. Always. The number of moves, the number of segments is the number of moves. And the number of moves, it's always odd. It is always odd. So if it is odd, and we have 2 players, if Piero and I are playing, where's Piero? Piero left. Piero left? I think he did. Jordan, so see, if Jordan and I are playing, if I go first and Jordan goes second, so 1, 2, 3, 4, 5. The first one is the first turn. That's an odd number.
Yes.
So it's an odd number of plays. It's always going to end up with the first player. So it doesn't matter if we have 15 dots. If we have, so what if we have 1,001 dots? Who's going to win? It doesn't really matter. It's going to be the first one. It doesn't matter if we have 1,000,000 of these guys. It really doesn't matter. Now, when we first saw it on just 16 points and we started playing, it was kind of hard. It was kind of hard to see what was going on. Yeah, exactly. So, but figuring out who wins is not that easy, especially if you miss. Like some of you were counting, and then you counted 8 segments because you missed one. And the more points you have, the easier it is to miss those segments. Until you realize that one good way of doing this would have been the following. If you have 16, you just have a polygon of 16 sides. You have a polygon of 16 sides. And then you can count the diagonals. The diagonals, this is, I don't know, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then you count the diagonals. You start at one point. You start at one point, and you draw as many segments as you can connecting the other dots. Look, 1, 2, 3, 4, 5, 6. Right? And can you do any? And then can you do anything else?
Yes.
What can you do there? You have 9 points. You have 9 plus. You have 9 plus what? 6. That's equal to 15. That's. What can you do? What can you do? What else can you do? Let's see. What else can you do? Let's see. No, that's already connected. It's this one. I see. I mean, maybe I didn't draw. Yeah, but that's that. All right. So it's basically the number of moves is just you can draw a polygon of as many sides as the number of dots you have, and then you stand at one point, and from that point you connect to all the other points, and that will give you all those. It'll give you all those diagonals nicely. You see? If you have 5, look. If you have 5. If you have 5 dots, 5. 1, 2, 3, 4, 5. Look, if you have 5, you go from 1. You go 1, 2. If you have, and that's it. So you have 5 and 2 more, 7. 5 points. You have a pentagon, and you have 2 diagonals, which is 7. 7 moves. An odd number of moves. The first player always wins. Okay? It's 10 o'clock, guys. I will see you again next week. Thank you for coming.